Hey gang, I am on the last type of form for the quadratic equation. Remember we had three types of forms for lines. There was slope-intercept form, right? Then we had standard form. We did point-slope form a little bit. There are three types of equations for quadratic functions, parabolas as well. Okay? We've clicked off how do you graph a function in vertex form. That was the first thing we did. We just got done with how you graph a quadratic function in standard form. So we're moving on to the third lesson essential question, which is how do you graph a quadratic function in something called intercept form. Okay, then look, see, we're done with all the forms. That's the third one. Okay, so let's look at this equation. Y equals x plus 2 times x minus 3. That's not in vertex form or standard form. I don't know what to do with something given to me in this form. Now, one thing I can do is change it to a form that I'm used to. That's what we did with, that's what we did with point slope form. Like a lot of times we'd have a line and we'd put it in slope intercept form so that we could see it better, right? So we'd understand it better. So, and then we know the slope, we know the intercept. That's what we're going to do here. I'm looking at this and I'm going to use FOIL to change this to standard form. Okay, so you can go ahead and do that on your paper if you'd like. I'm taking x times x, that's x squared. I'm taking x times -3, that's -3x. I'm taking 2 times x, that's plus 2x, and then minus 3. Or minus 2 times 3, which is 6. Okay? And then, of course, we combine our like terms. -3x plus 2x is a -1x. We don't usually write the 1, but there's an understood 1 there. Okay? Now, that's standard form. I have that a equals 1, so that's the number in front of x squared. I have that b equals -1, that's the number in front of x, and I have that c equals -6. Okay, so from last week, I know that the y-intercept, if I put 0 in for x, I get -6. The y-intercept is always c, right? I know how to find the vertex. To find the vertex, I take the opposite of b over twice a. So that's going to be the opposite of -1 over 2 times 1. So my vertex is a half, a half something. I'd have to put a half back in for x. Okay, so I'm going to take a half squared minus a half minus 6. You can do that on the calculator. A half times a half is a fourth. A fourth minus a half is negative a fourth, right? That would be 1/4 minus 2/4. That's negative a fourth minus 6. I get -6 1/4. If you did it in your calculator, you took a half squared minus a half minus 6. You probably got -6.25, whatever. Okay, so those are 2 points. If I want a couple other points, I might stick 1 in. 1 minus 1 is 0. If I put 1 squared is 1. 1 minus 1 is 0. Minus 6 is -6. Oh, that was reflected across there. Well, let's just see what happens. I already graphed it for you. Okay, just to save time on the video. Okay, so notice what I graphed was 0, -6, 1, -6, a half, -6 3/4. Okay, and then when I found these, when I put 3 in, 3 squared is 9. 9 minus 3 is 6. 6 minus 6, I got 0. All right. So that's 1 2.5 away from my axis of symmetry. So I went 1 2.5 in the other direction. I got these -2 3 and 3 0. Okay. So what I want you to notice, the original way we got this, the original equation was not given to us in standard form. We manipulated it into a form we were familiar with so that we could graph it. That's fine. It originally was x plus 2, x minus 3. And I want you to notice the x-intercepts. The x-intercepts are -2 and +3. And if you think about it, if I put +3 in for x, 3 minus 3, that's going to give me a 0 here. I'm going to have 0 times 5, which is 0. If I put -2 in for x here, -2 plus 2 is 0. And 0 times -5 is 0. So putting the opposite of what's here in for x gives us the intercepts. Let's see if that works over here as well. Okay, this one is not in vertex form. Okay, you see it? Not in vertex form. So what we're going to do, same thing, FOIL, change it. Okay, x squared plus 4x plus 1x plus 4. Add 4x plus 1x, you get 5x. Now, differently than last time, I have a number out here to distribute through as well. -4 times x squared is -4x squared. -4 times 5 is -20x. -4 times 4 is -16. Okay? So again, I could find my y-intercept. That's always the first thing I look at because putting 0 in, I see I get -16. Right? That's the y-intercept, not the vertex. The vertex occurs at the opposite of b over twice a. So I'm taking the opposite of -20, which is +20, over 2 times -4, which is -8. So my vertex is negative. Let's see, 8 goes into 20 twice, -2.5. Okay, because this reduces if I divide by 4 to 5 halves. So my vertex is -2.5. I don't know. I'm going to have to take -4 times -2.5 squared minus 20 times -2.5 plus 4. Okay, I'm going to stick it in there. Whoops, make sure my -4 is out here. Oh, no, never mind. I'm putting it in the bottom thing. Okay, sorry about that. I'm putting it in here. So I'm going to take -4 times -2.5 squared minus 20 times -2.5 minus 16. Okay, so I'm going to stop this a minute and bring my calculator. Okay, I want you to notice how I entered this on the calculator. -4, I put my parentheses around my -2.5 with the square outside the parentheses. That's so important, guys. You want to square the negative, okay? Minus 20 times -2.5 minus 16, and that will give me 9, okay? So my vertex is at -2.5, 9. Okay, and I have 0, -16. Let's just see what that looks like. We'll get rid of this a second. I already graphed it. Okay, so -2.5, 9 is my vertex. Okay, this is going by 2s. 0, 1 is halfway here, 2, 3, 4. Okay, so this is 9. -2.5, 9. The bottom's just going by 1s. I can't graph 0, -16. I don't have enough graph paper. I'm not going the whole way down there. Okay, so I needed a couple other points. So once you see that your vertex is at -2.5, what did we do? Sometimes we used our A, right, to go down 4, okay, from my vertex. I'm going to go down 4. 1, 2, 3, 4, right, and over 1. Okay, could go over 1 from -2.5 would put me here. So that would have given me those 2 points. And then I would have graphed around there. What I want you to notice are the intercepts. which I don't know in standard form if we ever would have gotten to, probably. I might have put -4 in, or I might have put -1 in just to see what I get. But notice, again, the original form was y equals -4 times x plus 1 times x plus 4. And my intercepts, whoops, were -4 and -1. It's upside down because my a is still -4. Okay, that's why this is called intercept form. All right? This is a new form called intercept form. Y equals a times x minus something times x minus something else. And what happens is, for example, in this, I'm bringing back up the ones we just did. In this one, I was opening up. A is still a +1. And look, it's still the same thickness or whatever wideness as our parent graph y equals x squared. It's opening up. Our intercepts were at -2 and 3. Here, my a is still the same. A through all these tell us the same thing. I'm opening down and I'm more narrow. And my intercepts are -1 and -4. Okay, so what do P and Q represent on the graph? The x intercepts. X, not y. It's not where we cross y. The x intercepts. Okay, so what if I was given this form now? Instead of changing it to standard form, finding the vertex, etc., how would I graph this now? Think about that for a second. Pause. Okay, hopefully the video kind of gave it away, didn't it? They represent -3, 0, the x-intercepts, and +1, 0. Now, I'd like to be able to find the vertex. And to find that, guys, the vertex is always halfway between your x-intercepts. Okay? So 1, 2, 3, there's 4 spaces between here. The vertex is going to be right here. I know it's below here some way because my parabola is opening up. So I know it's -1 something. Okay, the other way we could get that is to just add the x coordinates together and divide by 2. That gives you the x coordinate if you can't eyeball it and see it, okay? You take your x-intercepts, add them together, and divide by 2. Now I know my vertex is at -1 something. -1 what? Well, I'll put -1 in for x. -1 plus 3 times -1 minus 1. Everywhere there's an x, I put -1. -1 plus 3 is 2. -1 minus 1 is -2. 2 times -2 is -4. So -1, -4 is my vertex. And I'm pretty much done if I get my vertex and my intercepts. In some ways, I like this form the best. Because I have 2 points. I go halfway between. I have my vertex. Boom. I know that A tells me which way it's opening. Right? It's kind of nice. All right, so here are the nuts and bolts if you want to write the nuts and bolts of graphing quadratics in our new intercept form. The x-intercepts will be P0 and Q0. Okay, as long as these are minuses. If this was a plus, this would be -Q0. All right, if this was a plus, this would be -P0. The axis of symmetry will be x equals the vertex, which we just said was what you get when you add P and Q and divide by 2. To get the y vertex, you substitute, or the y part of your vertex, you substitute the x from up here to find y. And the y-intercept, you still do the same thing that we did every single form. We put 0 in for x and see what we get. Okay, let's go on to this example then and try it. Okay. I'm going to wait for this for the next video, but you can get started on it while you're getting the next video up. Okay? See you for part 2.